Hello, I'm Michael Oppenheimer, head of the Center for Policy Research on Energy and the Environment, and this is the Center's Bradford seminar. Our speaker today is Kyle Meng. Kyle is an associate professor at the Bren School at UC Santa Barbara and also a member of the Department of Economics. He's also a climate and energy program director of the Emissions Markets Lab at UCSB and a faculty research fellow at NBER. Kyle received his PhD from Columbia's rather unique and successful Sustainable Development Program after he received his bachelor's from in CEE from right here in Princeton. A first-generation immigrant, he was recipient of the Paul and Daisy Soros Fellowship for New Americans. I first met Kyle when he was an intern at EDF almost 20 years ago. After Kyle got his PhD, he was briefly a postdoc in my group on an arrangement where EDF and I shared the support for his work. If this suggests a deep interest in applications that are of immediate interest to the full range of stakeholders, then all you need to do is look at the titles of his papers and his frequent preference for publishing in broad audience, high quality journals to verify his bias. Kyle's talk today seemed to have two different titles, and I'm not sure why. Maybe Kyle can explain it to us, depending on where I looked to see the information on it. But both are consistent with Kyle's producing work that targets problems that are directly in front of policymakers. It's either decarbonization of local air pollution disparities, or perhaps when do environmental markets worsen or improve environmental disparities, or both. The tagline on the latter is the case of US climate policies. I'm intrigued by both titles. Kyle, I hope you explain why they're the same, but please join me in any case in welcoming Kyle Meng.
Great. Thank you, Michael, for that introduction. It's very nice to be back at Princeton virtually. And hopefully in the next hour, my presentation will clarify any confusion from this title. So let me just share my screen and we can begin with proceedings. Okay. So
Kyle, can I just interrupt us? I forgot to say, if people have questions, put them in the Q&A function, not in the chat box.
Great, thank you very much. So let me just take a step back in terms of some of the work that I have been doing more broadly and kind of where this talk fits into that agenda. This is, by the way, an agenda that's a part of a bigger group in which I'm part of, and a lot of it kind of work based off of the Environmental Markets Lab here at UC Santa Barbara. So increasingly, I think there's been a lot of thinking and concern, not just about climate change, but about climate change and climate policy in a world that's already very unequal, okay? And so why do we care about this? Well, we're interested in decarbonizing the economies around the world, but I would say that not all forms of decarbonization strategies are quote unquote built equal, in the sense that you can reduce greenhouse gases in many different ways, but each of those pathways could have very different equity consequences along many important dimensions, okay? And importantly, a priority, it is not obvious how, as you decarbonize an economy, what that would necessarily do to disparities in important kind of economic circumstances, such as energy prices, right? Prices of other goods, final goods like food, for example, wages through effects to the labor market, and then as well, which is going to be the focus of this talk, in terms of local air pollution exposure. Okay, and when I say about, I talk about disparities, I mean like really disparities between what we think of like between disadvantaged and other individuals. Okay, and just to give you an example, in another domain, there's a lot of talk about, for example, the just transition, right? So you're interested in decarbonizing your economy. There's a certain segment of your economy that employs workers, maybe like in resource extractive industries, that depend on employment from those sectors. How do you actually help those workers in a way that you can decarbonize without, leading to economic dislocation for that sector? Okay, so increasingly, a lot of the questions we're trying to ask is, which decarbonization pathways would actually exacerbate existing inequities, and which would actually help us narrow inequities. So are there opportunities out there when we think about climate policies in ways in which we can introduce policies that doesn't necessarily make current inequities in the world worse? Okay, so that's the broader agenda. Now let's focus in on what we're going to be talking about in this for next hour or so. In a separate literature, but very now increasingly linked, there has been now systematic documentation of air pollution disparities between disadvantaged and other individuals. So people from low-income communities and people of color have systematically been exposed to more air pollution than other individuals. This is kind of broadly motivated a very large and growing environmental justice literature and movement. Here are these two figures showing you pollution disparities in North Carolina, and then a figure on the right showing you across the US for particulates in the US by Curry, Voorhees, and Walker. And increasingly, there is this kind of joint consideration, and you can see this a lot in the policy debates where people are talking about, well, as we're introducing climate policies, both federally and at the state level, and then really across the world, can we do it in a way that also gets at these very persistent, very pronounced disparities in air pollution, okay, in the US and elsewhere? So that's the kind of broader set of questions that this talk is going to try to tackle through two case studies. We're going to ask the question, as GHG decline, do local air pollution disparities, when I say local air pollution, I really mean particulates, NOx, and SOx, do those disparities between the haves and have not widen or narrow? The thing that kind of piques our interest as academics is that actually the answer to this is not at all obvious, okay? And for a few reasons. First, when you're reducing greenhouse gases, well, greenhouse gases are oftentimes co-produced with local pollutants like particulates, NOx, and SOx, but not always. And that relationship differs in different settings, in different industries, in different time periods. But also very importantly, when we think about pollution disparities, you're actually characterizing a very complicated joint spatial distribution between where pollution is coming from and their abatement costs, okay, which is what policies would affect, and where households live. Where do people of color live? Where do low-income households live? Okay, and that's spatial distribution. So if you just think of it this way, as like trying to think about where pollution is coming from, where it travels and where it goes, is actually a very complicated problem with no obvious answer in terms of what happens if you just reduce greenhouse gases across a certain area. What does that actually do to local pollution? And in particular, there are two main challenges, kind of research challenges in this space. The first is you have to figure out how to actually estimate changes in the spatial distribution of pollution emissions, where pollution is coming from, due to some kind of policy of interest. And then you have to go through the kind of exercise of converting those emissions into, which is like from like factories and smokestacks, into where people live. Okay, you have to actually map emission sources to where it eventually ends up going, to emission concentration. This talk is we're gonna look at two settings. I'm gonna present to you two papers. Both settings is of interest because they represent examples where we have seen in the last 2 decades what I would consider pretty dramatic declines in greenhouse gas emissions, okay? In a period in which emissions have declined, okay, while overall economic activity has continued to rise. This is the case of my home state, my current home state here in California, and then more broadly across the US. These are, admittedly case studies, but I would argue very important, not just because of the size of the economies we're talking about here, but in some sense, this is very unprecedented. I at least don't know of many examples in modern economic history where you have actually seen a decoupling of greenhouse gases and economic activity, okay? And that's what these two panels are showing. And we're gonna look at these two settings in kind of, with different approaches to think about what has happened as these, decarbonizations occur, what has actually occurred in terms of local air pollution disparities. So the first paper is gonna look at California, and in particular, one of the key policies that have been critical for the state's climate strategy, which is its greenhouse gas cap and trade program. The methods here in trying to isolate the first challenge of trying to just basically figure out what happened to emissions is we're going to just bring in a pretty standard causal inference framework, treatment and control, thinking about facilities to treat it under the program and those that are not treated, and then estimate what happens to those emissions and then see where those emissions go. The second, we're going to look at the second paper, we're going to look at overall in the US, in the electricity sector only, and think very carefully about what has happened in the last 20 years as the electricity sector in the US has transitioned from coal to natural gas. Here, it's a lot harder to do kind of like causal inference framework because this is like a very macroeconomic phenomenon across the US. So we're going to bring in a statistical kind of approach that has a long tradition in economics, which is just like a decomposition of trends and its various forces. In both papers, I want to stress the following. This is a little technical, but I think it's very important to getting this right. We need to think very carefully when we're thinking about local air pollution. Okay, again, that's not a concern with in terms of greenhouse gases, but with local air pollution, we need to think about where the pollution goes. We need to actually do, I think, a good job of trying to respect where air pollution actually disperses. So we're going to try to think very carefully of how to kind of combine standard statistical or econometric approaches with basically air pollution modeling. And I'm showing you this graph here because in the standard way, at least from the social sciences, we've been doing this, we have largely just kind of assume pretty crude air transport relationships. For example, here's a graph on the left showing you a power plant or a facility in a black dot. And most people historically would say, well, that emission comes out from that black dot and then just stays within the grid it's in or the county that it is in or so forth. Or other people will say, well, maybe we'll have a certain kind of radius, pollution would travel along a circle, showing you here in the figure on the right, but that pollution basically stops moving once it hits the outer bounds of that circle. Okay. The reality, of course, is I'm showing you now two figures from our two studies showing you where pollution actually went, okay, for two facilities, and showing you that basically in reality, of course, air pollution transport is a very complicated process that's a function of topography and atmospheric conditions. And in earlier work that I've done in a handbook chapter that I've written with my colleague Olivier Deschamps at UC Santa Barbara, we actually formalized the bias in results and pollution exposure results that you would get if you don't actually carefully model where pollution goes. And so what we're going to try to do in this kind of broader effort, and in particular in these two papers, is to think very carefully about how you can couple and embed pollution transport modeling, which has largely been in the domain of atmospheric physics and atmospheric chemistry, into statistical frameworks that social scientists broadly have been using to understand pollution disparities. And in that sense, it's a little bit technical, but in that sense, we think this is like a very important methodological event that's kind of at the interface between kind of the social science community has been working on these problems, and the kind of atmospheric physics and science community has been working on these problems. All right, so let me just kind of dive into these two papers. Okay, the first paper is joint with Dade Hernandez-Cortez, who's an assistant professor at ASU. And here we're asking the following question. California has introduced a carbon market, a greenhouse gas emissions trading scheme, also sometimes known as cap and trade. Has this program widened or narrowed local pollution disparities? Let me take a step back to talk a little bit of the broader context for those of you who are not familiar with this space. A carbon market or a carbon price is broadly what economists call market-based environmental policies. In many domains, they have been increasingly adopted over the last 2 decades. So by some count today, something like 30% of global fisheries have some kind of market-based policy introduced to it. Ecosystem payment services, which is kind of like the equivalent of this in the ecosystem, in the conservation domain, valued around 36 billion. And by some count today, something like 20% of global greenhouse gas emissions are regulated under some kind of carbon price, and this number could double. Why have we seen this increasing popularity? Well, the traditional appeal of market-based policies is that it leverages market forces to spatially reallocate where pollution occurs, in this case, where greenhouse gases, and then the co-pollutants, local pollution, where that would occur. Why is that important? Well, greenhouse gases and local pollutants are emitted from many different sources, all of which have very different cost of abatement. Some sources are more costly than others. when you have this dimension of heterogeneity, it becomes important for you to leverage forces that get more emissions cuts from more costly sources, right? And so there's an argument that says that if you use kind of something like a carbon price, you can achieve your emissions target at lower overall cost to your economy. Why do you care about lower overall cost? Well, that would just translate to lower increases in energy prices, for example. Now, the concern increasingly over the last 10 years has been that this very kind of reason for why you will like a carbon price, because of the fact that it leads to lower cost of abatement and economic efficiency. Well, this very mechanism is achieved through spatially reallocating where pollution is occurring. And it is possible that in this process, that the spatial reallocation actually leads to local pollution disparities, which we know are already pronounced in many places, including California. It could actually lead that to widen as a result of the carbon market. The reason is very simple. Carbon markets are not designed for equity. Carbon markets, like any markets, are not designed for equity objectives. It's designed for kind of efficiency objectives. And so it is possible that because it's not putting a weight or kind of priority on equity, that a carbon market could actually widen pollution disparities. Okay, so that's the kind of general context. We're going to study this in California, which has had in the last couple of decades the world's second largest carbon market. Introduced in 2013, covers about 85% of California's emissions. The only economy-wide cap and trade program in the US, and the second really in the world in terms of size, second to what the European Union has. And importantly, within this program, there's this eligibility threshold that says facilities of a certain size get regulated, facilities of below this threshold do not. And this kind of setting allows us to basically introduce a quasi-experimental setting with a treatment and control setting. What is the kind of concern here? This pollution disparity concern about California's carbon market has actually been there for a very long time and remains a very, very salient concern even to this day. As I mentioned, California, like much of the country, has a very, very pronounced pollution disparity, like pollution gap between the haves and have-nots. And the concern was that the introduction of this cap and trade program, even back in 2011, when people were talking about the design of this program, there was this concern that this gap could widen, okay? And in fact, this concern has been present since, in renewal efforts since the introduction of the program in 2017, and actually in very, very much in current debates right now about what would happen to this program. So the research question for us is really, as kind of like applied econometricians, we were thinking, well, okay, so you have a pollution disparity gap in California. What happens to this gap when you introduce a cap and trade market? It could widen, consistent with concerns, with environmental justice concerns, or it could narrow. And the reason why actually this is an empirically open question is that there's no kind of body of theory that pins down that this gap necessarily has to widen or narrow. Again, it has to do with the spatial distribution of where polluting facilities are, that are regulated, where people live, and the cost of those facilities. In the paper, we kind of walk people through what this means, but the way you can think about it is that it could widen if steep polluters with kind of steep abatement costs tend to be upwind of disadvantaged communities, or if they tend to be upwind of other communities, this thing could narrow. Okay, and so our exercise really is to just bring the data to this question and see what happens. So the data is from pretty standard sources. I won't go into great detail here. It's coming from the Air Resources Board, the regulator that's in charge of regulating the cap and trade program. We have emissions for every year across both greenhouse gases as well as local pollutants for regulated and unregulated facilities. We have it every year for years before the introduction of the program and after the introduction of the program. And we're only going to focus on facilities from the industrial sector that were regulated solely by this program, so as not to kind of conflate the roles of all other programs that could be there. We use a legally defined, or kind of a California legal definition of a disadvantaged community. What does that mean? There's a policy in California from Senate Bill 535 that actually designates which locations, which census tracts are considered disadvantaged based on a number of demographic and pollution kind of exposure metrics. This is a definition that the state uses for policy reasons, and this is a definition that we're going to employ. Our approach is 3 steps. So what we're going to do is we're going to estimate what the program did actually to emissions facilities of emissions from facilities. Okay, we're going to then take this emissions, feed it into an atmospheric transport model to see where it goes, and then just answer then what happened to gaps between disadvantaged and other communities as a consequence of the policy. And just to give you a sense of the of where disadvantaged communities are in California, I want to focus your attention to this map on the left, where the dark shaded areas are those that the state has legally defined as being considered disadvantaged. So we're going to basically look at showing you comparing the dark blue regions to light blue regions and see how pollution disparities have changed, in the lead up to the program and then after the program. Just a quick aside, where I'm not going to show you too much math here, but basically in terms of estimating the effects of the policy, we're going to look at differential emissions trends, okay, before and after the program between regulated and unregulated facilities. The reason why this is important is that because we know local pollution responds to all forms of macroeconomic forces, including energy prices, okay, as well as to other kind of policies that the state and the federal government has introduced in this setting. So it's going to be important for us to have a control group and to allow basically for us to estimate how these differential emissions trends change before and after the introduction of this program. And so in the parlance of kind of, among economists, the identifying assumption that we're going to have here is that these differential emissions pre-trends would have continued if not for the introduction of the carbon market. Okay. These emissions might not, these coefficients might not mean very much, but let me just summarize what they're picking up. Each column is showing you a different coefficient. This is from a panel data model with our differential trend break model for CO2 equivalent, particulates, PM2.5, PM10, NOx, and SOx. The first coefficient, capital 1, is showing you the differential pre-trend between regulated and unregulated facilities in the years leading up to the program, which is the last year being 2012. And then the first year of the program, 2013, shows that differential break in this pre-trend for each of these pollutants. How do we interpret this? I would focus your attention on just the bottom two lines, which basically shows that since the introduction of the program, from 2012 to 2017, greenhouse gas and criteria air pollutant emissions fell by 3 to 9%, depending on which pollutant you're looking at, per year as a consequence of the program. If you just want to focus on greenhouse gases, that is an abatement of about 3 million tons of CO2 during this period. Okay, so we have these, we estimate what the program did to emissions. Now we actually need to see what it does to where pollution ends up. And here we use a atmospheric transport model known as high split, which models the trajectory of every single one of these particulates and where it goes. This is a very, very computationally intensive process. We have modeled over 2 million trajectories. And just to give you a flavor of what this means, here's a kind of a little movie showing you for every single regulated facility where pollution disperses across the state over just a 1-day period. Okay, so now you have several hundred facilities that we've modeled the cap and trade emissions effects for. We feed it into this atmospheric transport model, and we figure out where this pollution goes, and then collapse that onto census tracts to see whether or not this widened or narrowed the gap among disadvantaged or other communities. So we run this for several hundred facilities every 4 hours for a 10-year period. And it took a few days to do on several thousand kind of nodes on a high performance cluster. Okay, so to kind of walk you through what this looks like, we can take that and we can now look at what pollution disparities look like across the state for PM2.5, PM10, NOx, and SOx. So all of this, what are the results? So what I'm going to walk you through is the average difference in pollution exposure between a disadvantaged community and a non-disadvantaged community, again, legally defined according to the state of California, and how that difference changed over this period, okay? So the first thing to show you is what happened in the first year in which we have data, which is 2008. We call this statistic as pollution disparity the EJ gap, but it's basically just a difference in particulates between disadvantaged and other communities, and indeed consistent with EJ concerns and the literature, there was a positive gap in 2008, okay? So we noticed very well that people in California of lower income tend to be exposed to more pollution than those that are not. Interestingly enough, we find that among the facilities of our sample, industrial sources, the resulting gap was worsening in the years leading up to the introduction of the program. That is, the gap was widening between disadvantaged and other communities in terms of the pollution that they were exposed to from our sample facilities. What we then find is that after the introduction of the program, which is now shown to you here, after 2012, we find that this trend not only slows down, but it slows down so much so, right? So this trend that was previously rising slows down so much so, such that it actually starts falling, okay? Such that the gap in absolute terms have actually narrowed to the point where by 2017, the last year of our policy, it has narrowed, the last year of our data is narrowed to the point roughly to where it was in 2008. So the cap and trade program has actually narrowed the pollution dispersion gap between disadvantaged and other communities. Hasn't eliminated it, okay? But it roughly narrowed it back into, 5 years later into the program back to where it was in 2008. This is a pattern we see very robustly for PM 2.5. We see that as well for PM 10. We see that for NOx, and we also see that for NOx. So the statistical precision for our NOx results are not as strong. In the paper, we go through a bunch of robustness checks to see that these results hold across various different assumptions across our 3 steps. But the one thing where it does not hold is if we abandon the use of our pollution transport model. So we also in our paper take care to kind of apply more standard techniques where we say, oh, pollution from a source just basically stay within the zip code that the source is in, or within certain rings of arbitrary radii, kind of standard approaches in the social sciences. And then that's when our results kind of bounce up and down and kind of are not consistent, as shown here in this graph. So the main result here is showing you in the solid circle with the confidence intervals. This is actually the break. So this is the trend break after the introduction of the policy. And you can see that we use these different ways of just assuming that pollution stays only within a zip code or stays within some kind of circle around the zip code. This coefficient ends up being very, very noisy and kind of inconsistent, okay? And so really one of the lessons we take from this, and I think we take from this kind of broader agenda, is that we really need to model very carefully, kind of respect the atmospheric physics to understand where pollution is actually going. So bringing in these tools from the atmospheric science community into our work on these social science questions. Okay, so that's the story from California. California's carbon market looks like it reduced pollution disparities across the state, hasn't eliminated it, but it certainly has not worsened the pollution disparity problems, at least from sample facilities that we consider. Now let's turn to the second question, which is about what's happening overall in the US. And this is work again with Donna Hernandez-Cortez, and then now also joined with Paige Weber, who's an assistant professor in economics at UNC Chapel Hill. So the question that we are interested in here is to say, well, actually, let's just take a step back and think about what are some major forces that have occurred in the US electricity sector, okay, over this period. Here are what we think of as two, in a kind of national sense, two very important forces. On the left is a time series showing you the share of kilowatt hours across fossil fuel using electricity generating units in the US from 2000 to 2018 between coal in blue, natural gas in green, and oil in red, okay? This is a story that many of you guys have been hearing about and probably have and have studied, which is that there's been a decline in coal use in the US at the same time as there's been an increase in natural gas use. Okay, and this is largely, we think, associated with the kind of introduction of relatively cheaper natural gas following the introduction of hydraulic fracturing. Okay, and a lot of the commentary has been that the decline in U.S. emissions, which I showed you earlier in the introduction of the talk, most of that is actually almost all of it's coming in from electricity, and most of that looks like it's coming in from, or there's an association with the kind of low natural gas prices as leading to this coal to natural gas fuel switching. So this is a decarbonization story. On the other hand, there's been an interesting pollution kind of intensity story where now I'm plotting for you data for the same time period of pollution emissions, so like NOx and SOx, per unit of kilowatt hour produced on average across fossil fuel generating units in the US. I want to focus your attention again to the lines in blue, which are showing kind of really dramatic declines in pollution intensity, okay, in both NOx and SOx coming in from coal, all right? And then less clear patterns for generating units using natural gas and oil. The decline in coal pollution intensity is consistent with some other studies that has been done showing kind of the cleanup in general of the electricity sector over this period. Part of it perhaps due to the introduction of or various different variants of clean air policies like the Clean Air Act and their various amendments. Okay, the reason why this is of interest is that now, if we want to think about this period, you have on the one hand this massive switching from coal to natural gas, and as well a cleaning up, a differential cleaning up across different fuels. Now, the reason why, again, this has ambiguous effects on local air pollution disparities is that it all depends on where coal-fired units are located, where natural gas-fired units are located, how these trends are different across those units, as well as where people live, and then whether or not people are also moving over this period, okay? So we're gonna try to get at that. The data that we're gonna use is, again, panel data from 2018, our electricity generating unit data is a combination of EPA continuous emissions monitoring data, as well as that collected by the Energy Information Agency, EIA, which has information that we're going to feed to our atmospheric transport model. And then we're also going to have census tract level kind of demographic data during this period where we use a combination of this, data from the publicly available data from the decennial census and the American Community Survey to basically track for every single census tract across the US where people of different racial and ethnic groups are living and different income, and then as well as population, okay? And then in this case, we're gonna use a different transport model. We're gonna use a model known as InMap, which is actually allows us as an improvement from high split because it allows secondary particulate formation. So we can actually not just look at primary emissions, but like, you know, how NOx and SOx translate into particulates. And we do it at a very, very fine scale. So there's a InMap product that we use, which is at a 1 kilometer by 1 kilometer resolution that actually allows us to then map how pollution from individual smokestacks kind of disperse across the state. I'm going to talk to you about how we think of this problem. Here's a little bit of math, but really kind of just as a summary, the way we're going to think about emissions and their transport and how it affects people is that we're going to think of emissions as being a component of emissions intensity, share, which is kind of going to be capturing kind of coal to fuel switching, and then total output, okay, which is shown here in this Q. We're going to take this and we're going to feed this into the kind of the data that we get from the emissions transport model InMap to basically convert emissions from facilities onto the exposure for all census tracts across the US. And we're going to do this for every single emissions source in the US or every single EGU in the US. And then we're going to do a population weighted average of how concentrations have changed for each different demographic group. And that's what's shown here in the last expression. What does this look like? Here's a map showing you the distribution of PM 2.5 across the US in the last year of our sample, 2018, due to the power sector, okay? As well as in the black dots where the power plants or kind of generating units are located. What's really fascinating about this is that this pattern is uneven spatially across the US. There are certain places in the US that are exposed to more pollution from power plants than other facilities. We have the ability to decompose this by fuel, by changing demographics, by changing composition, and changing scale, which I'll show you in a few slides. If you were to just think about taking this map here and then just overlaying demographic information at a census tract level, what you will see is that if you take the population weighted average, that on average, Black Americans are exposed to more pollution from power plants, shown here in the middle bar, than white Americans. But also, actually, very interesting enough, white Americans are exposed on average to more pollution from power plants than Hispanic Americans. Okay. What's interesting now is to think about how these gaps have changed over this period. Oh, by the way, and we actually see an income gradient roughly as well. That is, poor Americans, shown here on the left in terms of like an income decile, are exposed to more pollution on average than richer Americans, shown here on the right. So the first thing we plot is let's look at this gap and see how this gap actually evolved over time. Now, consistent with other work that's been done, including work by Princeton's Janet Curry, we find that the gap in pollution disparities between Black and white Americans, just from the power sector, just from pollution from the electricity generating sector, that gap, which is shown here as the difference between this gray and black line, has been declining. But not only has it been declining, but it's been declining pretty dramatically. So if you can see the size of this gap in 2000 and the size of this gap at the last year of our sample in 2018, this is a fall of about 95%. Interestingly enough, white Americans are exposed to more pollution than Hispanic Americans, but this gap has actually also been falling, or you can think of it as like the Hispanic white gap, in which case that gap has been rising, okay? So there's been a general convergence overall in terms of pollution exposure across these demographic groups. If you look at income, there's been very little change. Now, income itself has, in general, people rich and poor have been exposed to, less pollution over this period. But the difference between the top first percentile and the bottom 10th decile in terms of income distribution every year, that has changed very little. So a lot of this story has to do with actually changes in pollution exposure by race. So what's driving it? Well, we can do it with our data, a decomposition effect. We can actually think about 4 potential forces: the scale of the overall scale of the electricity generating sector, emissions intensity effects, so changes in how clean each facility is over time. We can think about composition, basically for each facility, how much are they using coal and natural gas and oil to a certain degree. And then we can also, in the last part, also think about where people are living, whether or not changing spatial patterns of where people live have, over these last 2 decades, led to these changes in disparity. This is what this decomposition graph is showing you. So here I'm now just showing you the gap between Black and white Americans on average. The actual gap and how it's fallen is showing to you here in the blue line, okay? So that has fallen by around 95%, okay, during this period. About half of that effect is due to just the scale of electricity generating units producing less overall across the US during this period. Another half, about 50%, is actually due to the cleanup. That is, turns out that allowing facilities to use, to clean up has actually lowered this gap by about 50%. I'll show you a mechanism for why we think that's been going on. Fuel switching has had very little effect. Fuel switching has had about 5% of an effect. And sorting, kind of where people have moved over this period, has had negligible, kind of rounds out to about 0%. Contribution to this overall fall in the Black-white pollution exposure gap from power plants. The story is basically the same when we think about the Hispanic white gap. Now, this trend is increasing because we're taking the Hispanic exposure relative to the white exposure. So as you can see, there is convergence, but now because we're kind of flipping the order of the groups, this trend is actually rising. But again, this story has a similar flavor to the Black-white gap, which is it's fallen overall in terms of the actual data by over 90%. Most of this is due to cleanup. Very little of this is due to fuel switching, okay? And about 1% due to a changing composition of where people live. Why do we think this is going on? Well, here's a kind of plot showing you on the x-axis across different census tracts, okay, across different emitting facilities, how much emissions intensities have improved for that facility over the last 20 years. The places that have cleaned up the most are shown here on the right side of the graph. And these generating units, these power plants, if you will, are also more likely to be upwind of where Black Americans live. So the places that have been cleaning up the most are also the places that are more affecting Black Americans, perhaps having to do with certain details about how the Clean Air Act and other air quality policies have been implemented over the last 2 decades. And because you're cleaning up facilities that are differentially affecting Black Americans, that is leading, we think, to just narrowing of the Black-white gap. If we were to think about the fuel switching story, here are 2 bar graphs where we've broken out pollution exposure on average from the power sector, but broken out by coal and natural gas. And we've also divided pollution exposure by just the total amount of pollution from those 2 fuels, and in terms of local air pollution. And what you see is that actually coal-fired power plants do not tend to be more upwind than natural gas power plants. Okay, so even as you're fuel switching from coal to natural gas, you're not doing it in a way such that you're going to favor one group over the other in terms of who is quote unquote downwind of those facilities. Okay, and so the story we see pretty consistently in the data is that here, what we think has been the main driver of decarbonization of the electricity sector in the US over the last 2 decades, which is fuel switching coal to natural gas, has not really led to a narrowing or changing of pollution disparities across the country, but rather it has to do with these other policies that have been cleaning up these sectors, the electricity sector, in a way that has differentially favored Black Americans over white Americans. Okay. All right. So I have 1 more minute. Let me just kind of conclude in the following manner. So where we're showing these 2 papers is that these 2 case studies of decarbonization has actually had very different consequences on local air pollution disparities. In California, focusing on industrial sectors, the carbon price, the cap and trade market in California has indeed lowered air pollution disparities for these coming in from these facilities. Now, looking kind of broadly in the US in the second paper for the electricity sector, we do find that this Black-white pollution disparity has fallen over this period, or you can think of it as like this negative Hispanic-white disparity has risen. So there's been a convergence overall in terms of pollution exposure across these 2 groups. But we actually don't find, the data is not suggesting this is due to coal to natural gas fuel switching, which is broadly the story we think of as when we think of decarbonization of the electricity sector. It looks like it's being driven by differential emission intensity improvements coming in from other forces at play over the last 2 decades. And in both cases, we demonstrate that it's important kind of integrating pollution dispersal modeling to come up to arrive at these results. So what are some of the messages moving forward? Can we say something more broadly? Certainly, for sure, you can say that, well, decarbonization, at least from these 2 case studies, is not always going to be associated with reduced air pollution disparities. So one might say, well, okay, so do we have to do this in a case-by-case manner for every single case out there? Like, are there any general principles we can learn? And at the moment, we're not quite there yet. This is part of a broader agenda that Dane, Paige, and a larger group of us are trying to get at, thinking about kind of the broader principles under which, with available data, you can actually kind of do some forecasting to think about when different forms of decarbonization strategies would widen or narrow pollution disparities. But it is important to still do some retroactive studies, as I've shown you here. And in this case, we're giving you an example where that has been the case. Decarbonization has been associated or has caused pollution disparities to narrow. And in a case in which it doesn't look like that's been the case. Finally, let me take a note to say that even if we kind of understand this more broadly, it is very hard to understand kind of out of sample what would happen in many other settings. And in particular, if we're very much concerned about pollution disparities as its own kind of criteria when we're trying to design environmental policy, my own view on this is that it's one thing to think about pollution disparities or EJ concerns in tandem with climate policies, but really from an economic standpoint, if you have 2 problems, you need 2 solutions. And what you really need to do is have EJ specific or pollution disparity policies, in particular, such that you can directly get at pollution disparity concerns and not just load all these concerns onto the design of climate policy. And so a lot of the thinking we have moving forward is to think about, if you are to kind of jointly in tandem tackle these two problems, how do you kind of, design both climate policy in consideration or in tandem with pollution disparity kind of EEJ policies, so that you can kind of jointly meet both objectives. I'm happy to talk about that some more in the Q&A, but that's broadly where we're going. Thank you.
Thank you, Kyle. That was a great talk. Fascinating. I had seen that with the working paper years ago, 2-3 years ago. And just let me quickly ask this question before we go to the people in the Q&A box, which is, you came out with this study, and then during the, after Biden won the election, there was some talk that Mary Nichols was going to be appointed. She's a longtime director of the California Air Resources Board, that she would be appointed as the as a head of EPA, and it didn't happen. And the scuttlebutt was that she had slipped. People were mad at her in California because of the way she'd implemented the California air pollution plan in a way that we didn't focus enough on environmental justice concerns. Did you get any blowback when your study came out and started to receive some attention, and which I assume it did, from people who thought that was a little too much evidence in there one way or the other?
Yeah, it's a good question. As you know, that these questions about carbon markets and environmental justice have in the last few years been very contentious, not just here in California, but nationally. It's interesting. We have a stance that actually on this that kind of takes a little bit of both sides, which is that if you look at the California example and your concern is about the market forces leading to pollution disparities, widening, that does not look like it's happened, at least not from the facilities in which we can actually isolate the effect of the carbon market. It does not look like it's happened over the last, the period up to roughly now. Does that mean we shouldn't, moving forward, think carefully about EJ specific policies? I think that's wrong. I think it would be wrong to interpret our results as saying you can solve EJ problems with a carbon market. I think that would be a wrong interpretation of our results. Our results just simply says it does not look like the carbon market has worsened these problems, but there's no guarantee that it couldn't moving forward, or it couldn't do that in other settings. And the reason is that a carbon market is not designed for equity, just like any market is not designed for equity. It could improve equity, it could worsen equity. And so a lot of where I think some of the most important thinking is moving forward is, if you do have a carbon market, how do you put safeguards on them? How do you actually have safeguards introduced such that pollution disparities do not widen, because they could? Now, the market itself might actually not lead that to happen, which is what looks like it's been empirically in the past, in which case, great, your safeguards are just safeguards. They don't actually, end up being activated. But if they do, well, then you want those safeguards in place. And so, again, the summary is that the carbon market has not widened disparities. Does that mean we should just load all EJ concerns onto carbon market designs moving forward? No, that's not what we think. We think you should have EJ or local environmental policies considered in tandem with carbon markets, such that you don't actually have these kind of adverse consequences moving forward.
Okay, so now let me call out the people who put comments in the box. First of all, there's a very relevant question. The first question is, Seung, if you want to turn on your microphone and step up and talk directly, you can call out your own question.
Hi, can you hear me?
Yes.
Yes.
Awesome. Yes, thanks for a great talk. So I'm curious about the results from the first paper you discussed. And I was curious about the mechanism behind why we are seeing the carbon markets are actually reducing the EJ gap. And one specific question I had was, do firms relocate after the cap and trade policy, or do they mostly stay in the same place and adjust their operations to comply with the cap and trade market? In other words, reducing pollution quantity itself. And more broadly, like, what are the explanations for what had happened in California?
Yeah, so good question. So our framework, we take the data as given. So if there's any entry and exit of firms in different locations, that shows up in our data. Now our data is kind of quote unquote short run. It's only like 5 years after the program, and so there could be a lot more of that, with a sustained carbon price moving forward. But whatever we pick up has some of those forces already at play. What's the mechanism? We think what's happening is the following. So if you think back about like your understanding of like carbon pricing 101, right? You have heterogeneous abatement costs across facilities. A carbon price will induce more abatement from firms with higher marginal abatement cost facilities. It looks like in California, firms with higher marginal abatement cost facilities also tend to be more upwind or are bigger, okay, or smaller, and so as a result, when you they're less upwind of disadvantaged communities, and so as a result, when you introduce a carbon price, they abate less, and so the improvements for disadvantaged communities are bigger than the improvements for other communities. Okay, so that's at least what we think is going on. Beyond that, it's hard for us with the data that we have to speak much more on the mechanism. On your point about movement more generally, we are, in terms of like people, we're holding where people live fixed in our California analysis. Now, it looks like overall people have not moved that much, but of course, in the long run, understanding where people go, and there's a very good chance that people are going to move, and we have evidence that people move according to pollution patterns, that's going to, we think, matter. We're trying to think about that in a different study right now, but that's outside the scope of what at least we're doing with the carbon market in California.
Good. Tong Liu, you want to read out your own question?
Can you hear me?
Yes.
Great, Kyle, thanks for a great presentation. So my question is also about movement, and in the short term, do you differentiate between exposure at the residence or people commuting on a daily basis to work? How would that change your environmental justice results? Thanks.
Yeah, no, I'm gonna have a very, you're not gonna like my answer. We're not even thinking about people's decisions after their, in terms of where they live. We're just looking at the gap in terms at the zip code level, right, in terms of their residence. So you're right that if you want to think kind of in a richer manner about people's avoidance behavior, well, you have to think about how people make choices in terms of where they work, how much time they spend there, and so forth. And that's something that we don't have the data for, and so therefore there's not much we can say about it. All we're saying is like, let's just see where people live and actually fix them to where they live before the program. And then ask whether or not those people or those locations really are exposed to more pollution than others. I'm just going to take an aside here. Actually, we've been doing a lot of careful thinking about when we want to think about pollution disparities, is the right unit of analysis where like location or people? Okay, I would say that actually the right unit of analysis is people, because exactly what you want to do is if people are moving, you want to track where people go. And so we are actually thinking very carefully about how to think about these questions when you have that kind of data. And we are starting to kind of have access to that kind of data. And the important story here really is like, think about your classic gentrification story. You clean up a place, great. But if gentrification occurs, the people who live there, right, are now priced out of that place. And so as a result, they might end up having to move to another dirtier place. And so they don't actually experience the benefits of that environmental cleanup. And in that setting, it is not at all obvious that inequality will actually narrow, and if not, could even widen from just a standard environmental policy where you clean up a place. So those are really interesting set of questions that we're trying to navigate right now as a group more broadly.
Okay, Nick, your turn.
Yeah, hi there. Thanks again. I'll echo a really interesting talk. My question was around the effect of transportation-oriented policies in comparison to point source-oriented policies. Is it possible to get a sense of how much things like the CAFE standards and low carbon fuel standards have also affected the racial gap in air pollution exposure? Thank you.
Yeah, it's a good question. That's much harder to do. So we had a team of us at MLab last year got a big grant to write a study for the governor of California looking at supply side policies in California. So like keeping oil in the ground and those pollution disparity consequences. So we actually have a study you can find it on my website that we delivered to the governor on refineries and extraction sites across the state. What we can't say is like cars. Like that is a really hard problem. I don't think you can run a transport model on like 300 million cars. And so we quickly run into some pretty serious computational limits there. And so we haven't been able to crack that yet. So in terms of actual like tailpipe emissions and those disparities, that's actually not clear. So there's some really interesting questions. So think about like what happens when you have electrification, right? So places that poor people tend to live near highways, and highways are polluting. If you have electric vehicles, those places actually end up being cleaner and has less noise pollution. And so there's some actually interesting, provided those people actually own their homes, which they often don't, but they do, there actually could be benefits for those communities. So these are some of the questions we think of, but we haven't quite cracked it yet.
Okay, the next presenter, the next question is anonymous, so let me just read it in the interest of time also. Thank you for your talk. I was wondering if you could comment on why, given your findings in California, EJ groups across the country still oppose cap and trade programs. Also, is there a way to embed EJ concerns in cap and trade style programs? I think you just answered the last one already, but do you have any speculation? Give us a little political economy here on why people don't like cap and trade, no matter what results might come out.
Yeah, I think I would say that's above my pay grade.
Oh, come on. Okay. I think you answered that already too, namely, look, this doesn't go to the source by source situation. And
I mean, I guess all I would say is that I can see where the concern comes from. And it's a very hard question to answer. I mean, to do this well, it's taken us years to do this. And so and we know pollution disparities is a real problem in California and in other parts of the world, and of course, certainly across the US. So I can see where these concerns arise, and answering it well is not easy.
Yeah, well, so PM2.5 isn't the only pollutant that's affecting people.
Yes.
So last one, Alice, go ahead.
Sure. Thanks, Kyle. I think this is already somewhat answered, but I was just wondering about how we could account for the exposure of these low-income residents when we know that a lot of these low-income residents probably need to commute long distances for work because they can't afford to live where their jobs are. And I think you already said that this is difficult, but I just wanted to throw it out there. So there's all these cell phone location data that you're able to track individuals and where they are on a day-to-day basis. So I wonder if you could use that to see not only just where they live, but also where they move around during the day when you're kind of estimating those transport model and where the pollution are.
Yeah, no, it's a good idea. We need to think a little bit more about this, but your suggestion is, okay, if we know the spatial distribution of pollution concentrations and we had high frequency mobility data, we can actually back out what their actual exposure is as a function of their daily mobility. Yeah. The question is, the problem is I don't think with the cell phone data you have demographic information, or at least very detailed demographic information, because if they did, that seems a little bit too snoopy in terms of that data being available. But we haven't looked into it, but that's something we could. Yeah, good idea.
Well, that about wraps it up, I think. Yep. So please join me in thanking Kyle immensely for this very interesting and topic and a topic that is in front of us day by day. Kyle, thank you very much.
Thank you. Thanks, everyone. Thanks for the invitation.